All right, page 2, model 2. So we're looking at types of waves. So this is types and properties of waves. First off, we want to draw the two different types of waves. So the students are conducting experiments, and you want to how would you make it, and what would it look like? So first off, how would you make the transverse wave here? All right, so the transverse wave, you want to move your arm side to side or back and forth. We'll say move your hand back and forth. But the key is, do you move it back and forth perpendicular, or do you move it back parallel to the way the wave moves? And so that's going to be the key for that. All right, so for the transverse wave, we're going to move it perpendicular to the wave motion. So that's going to be, if the wave is velocity is this way, right, then we're going to go up and down, up and down, kind of back and forth, back and forth. That's a terrible one there, right? Again, the wave's moving to the right on the page here, but the actual motion is going to go up and down, perpendicular to these two things here, all right? And then we want to label the crests. So here's a crest on each one, crest, and this is the trough. Crests and troughs. Again, vibration up and down with speed side to side. Whereas longitudinal, and now these are a little bit harder. And again, Mr. Ma showed me a kind of cool way to draw this, where you kind of count the number of lines you're making. So you want to make more particles close together for a compression, and you want to make fewer particles spread out for a rarefaction. So again, the motion itself, if the wave is moving to the side this way, the particles or lines or whatever you use are going to move back and forth this way, parallel to the motion. So we'll start out with a compression. So I'll put 3 lines right close to each other. And then I'm going to make a rarefaction. A rarefaction is just 2 lines further spread out. Then we'll make 3 lines close together. And then we'll make 2 lines further spread out. And then 3 lines close together. And then 2 lines spread out, right? And then 3 more lines right together. And so that kind of produces this idea of a compression wave. Now, these particles are kind of vibrating back and forth, as we showed there, but you have a little compression, and then you have a rarefaction. Rarefaction, or opposite of a compression here. So that's going to be that part, and that's going to be the compression there. Right. Then if you wanted to look at kind of the wavelength of that, the wavelength would just be the distance between 2 compressions. It doesn't ask you to label that, but that's what that would be. All right, next question. Students make 2 different waves as shown below. Wave A looks like it's going up and down, up and down, up and down. B is also going up and down, so they're both transverse waves, but it looks like A's kind of happening faster maybe. All right, anyway, draw a line to represent the amplitude of each wave. So the amplitude is from equilibrium to a crest or to a trough. So those are both amplitudes. You can go whichever one you want, amplitude. If you want to draw it over in the wave, you could do it there. You could do it here. I don't care where. Amplitude is from the equilibrium to the crest or trough. Same thing here, amplitude or amplitude. Wavelength is the distance between 2 peaks or 2 troughs or 2 consecutive points on a wave. So I'll do the hard one first. If I look up here and I see my wave starts right there and it goes up a little bit, I'm going to go find the next spot where it's going up. I'm going to skip that one other. That is my wavelength. Now, sometimes it's easier to just go from crest to crest. That could also be wavelength, or you can go from trough to trough. That also could be the wavelength. There's lots of different spots you could draw the wavelength. Same, the wavelength for the bottom one is going to be from the beginning all the way to where it starts going back up. That could be wavelength. Or you could go crest to crest. That could be wavelength. Or trough to trough. That could also be wavelength there. Lots of different ways you could draw that. All right. If each picture represents 1 second, so each of these happens in 1 second, which would have the longest period? So longest period means most time to happen. Remember, period is the time per cycles. And if I look up there, I can see that one wave, the top wave, has 1 second, and how many cycles happens? It goes 1, 2, 3, 4 cycles there. So that's going to be 1/4 of a second. Whereas the second wave has same thing, has 1, and then how many cycles is that? 1, 2 cycles. So 2 seconds. So the longer period would be the second wave. And then frequency is just 1 over the period. And so for each of the waves, for the first wave, it would be 1 over 0.25. The second one would be 1 over 0.5, which gives me a frequency of 4 hertz or a frequency of 2 hertz. And so for this one, we're looking at the first wave has the higher